Good morning and welcome to the Gear Technology and Power Transmission Engineering Expert Showcase Theater. My name is Randy Stott and I'm the Managing Editor of Gear Technology and Power Transmission Engineering magazines. And I'm pleased to welcome with me here today Scott Knoy, who is Vice President of German Machine Tools of America. And today we're going to be talking about scudding. Scott, can you give me a brief history of the scudding process and how it's developed over the years?
Sure. First, thanks for having me, Randy. I appreciate it. As you all know, the scudding process began over 100 years ago with the Hitler Company. And when they patented this technology, it was quickly apparent that the machine tools and the cutting tools were unable to handle the speeds and the torques. So that process really laid dormant for several years. Fowler had a hard scudding process in the mid-'80s, and in 2006, Profilator revisited this topic and said there's no reason we can't cut gears green using this process. And so we put this process on our horizontal line of machine tools. Since that time, we have determined that there's larger benefits to cutting larger gears. So we've also put in a vertical machine line up to 20 inches. And most recently, we've had a lot of requests for value-added operations.
Okay.
And so if you come to our booth today, you will see hard scudding. So we're finishing a gear in the hard at 62 Rockwell, but we're also doing hard turning and stock division on that machine. There is a turret included in the machine.
Okay. What type of applications is scudding good for?
Well, we always say if you can hob it, shape it, broach it, mill it, you can scud it. The form, virtually flexible. Any form you would like to scud, we can scud. It's the actual size and the clearance which determines if it's a good application for us.
Is there a size range that's best?
Since we only go to 20 inches, that's on the outside, and small, we would go as small as you'd like. We can go to 0.
And what applications would a manufacturer still prefer to use hobbing or shaping or broaching to achieve the same tooth forms?
I'll say this, if you can hob the part and you're going to use a finishing operation like grinding or honing, you hob the part. Your tool light's going to be much better, you have many more teeth on a hob than on a scudding cutter. But if you're looking for extra quality, scudding will help you out. The only time you would ever shape, if you could do both, is if the ID was too small and you couldn't get the scudding cutter inside of that, because we do use a setting angle. So there's a clearance issue.
Okay. You mentioned hard scudding, and I'd like to talk a little bit more about that.
Sure.
Has the introduction of hard scudding expanded the range of applications that you're able to use?
It has. As you know, automotive ring gears have always been an issue with quality. They're broached, and then they're heat treated, and then they tend to distort. So everybody is always looking for ways to improve that quality without added expense. So you can actually scud the gear instead of broach it, but it's very easy in scudding to make corrections for heat treat. You can crown, you can taper, things that you can't necessarily do with a broach, so we're much more flexible. We don't run quite as fast, but we produce a better quality gear, and we can give you a part where you can predict what's going to happen in heat treat.
Okay. Has it required a lot of changes in the machine tool to develop the technology for hard scudding, and what types of things were involved with that?
Strangely enough, it wasn't that difficult. Any scudding machine, whether it's a hard scudding machine or a soft scudding machine, is basically the same machine. The difference is the software package, stock division probe, and the name on the front.
Okay.
Say HS or S, but a hard scudding machine will also scud soft.
There you go. Now there's a lot of manufacturers who are doing skiving, high power skiving these days, and I'd like you to give me a little bit of an explanation about how scudding is different from what else is offered out there.
In 2006, when we started thinking about this process again, we quickly knew that once we came into the market, we'd have a lot of competition. And because we're not one of the larger players, we knew it would take a little bit of time, and we wanted to distance ourselves from the other competitors. So the way we look at it, and I'll say Profilator being our parent company, they look at it holistically. We want to control every aspect. In every instance, it's a dry process. If you look across the industry, people are doing it wet sometimes, dry sometimes, almost like they can't make up their mind. We control the design of the process itself, the design of the cutting tool, and the process optimization and reconditioning of the cutters. We control everything, soup to nuts. If you look out across the industry, you see a lot of people selling bits and pieces of the skiving process, but very few people are coming in with total ownership of that process, and we want to be that supplier.
Very good. In today's world, transmissions are optimized in every possible way. What sorts of tooth modifications are possible with the scudding process?
When you look at scudding, you can control the lead in infinite ways. The profile to a lesser extent. That's basically driven by the cutter. But with the HMI, you can control taper and crown in the lead, internal or external. You can also put asymmetry into a part because we can single flank finish with this. Okay. So if you wanted one side tapered and one side straight, that can be done. One side crowned and one side hollow, that can be done. It's infinitely variable with the software.
Okay. And what about surface finish? What types of quality can you get out of the process?
We can achieve, I know this only because I just looked at a chart, we are generally below an RA of 0.5. It's not quite grinding and honing, but in most applications, it's very good. Very good.
Would you say that most of the users are going to finish grind or otherwise finish the
It's
parts?
moving that way for several reasons, noise being the ultimate driver, and we also sell honing machines. And the three reasons you hone, one's noise, one's durability, and one's clearance. So unless you really need the durability part of it, there's no reason why you shouldn't finish scud. At least try it. If you have a scudding machine, it's not a big deal to retrofit it or to purchase it with the extra equipment to hard scud it. It's quite a cost savings. You can use the same machine. You can use, you need a cutter, a stock division sensor. That's it.
Okay. And what's next on the horizon for the technology? Is there something else that's going to be coming out?
When we look at scudding and what we do, Profilator has always been famous for combining processes. We've always been hobbing gear tooth pointing, scudding, polygon milling. So we're looking in that direction. We're combining processes. There's nobody really saying it's impossible to scud in the green, induction harden the part, bring it back, and recut it. So it's ideas like that that are floating around. None of them are ready for prime time,
Sure.
but we're thinking about it.
Okay.
Because we're a small player, we need to be more agile.
Very good. Is there anything else that you'd like to add and make sure people are aware of about the scudding process?
Well, as everyone knows, it's been out now for about 11 years. If you'd like to see the latest in scudding technology, please visit us at booth 607. We're going to show you again hard scudding, and we're going to show you also in the machine hard turning, and we have a probe in there for stock division, but can also be used for dimension over balls and other types of measurement.
Very good. Any questions from the audience? Scott, thanks very much for joining me.
Thanks,
It's been a
Randy. I
pleasure.
appreciate it.